अस्सलाम वालेकुम। सो आज हम क्वांटम मैकेनिकल प्रॉब्लम एक छोटा सा सॉल्व करेंगे। प्रीवियस हमने क्वांटम मैकेनिक्स के कंसेप्ट को लेके चलेंगे, जैसा कि हमने ऑपरेटर्स और कम्यूटेटर्स पढ़ लिए थे। सो आज हम उसी की एग्जांपल देखेंगे। आज हमने एग्जांपल करनी है कि हमने चेक करना है कि हमारा पोजीशन ऑपरेटर और मोमेंटम ऑपरेटर क्या कि कम्यूट करते हैं कि नहीं। कम्यूटेशन हमने जब पढ़ा था तो रिलेशन कम्यूट करने की हमने सबसे पहले कंडीशन पढ़ी थी कि आपकी दो ऑपरेटर्स कम्यूट तभी कर सकते हैं जब आपका रिलेशन उनका आंसर ज़ीरो आएगा। तो अगर मेरा पोजीशन ऑपरेटर और मोमेंटम ऑपरेटर का आंसर ज़ीरो के बराबर आ जाता है, सो आई कैन से इट्स कम्यूटिंग। सो लेट्स चेक। इफ नॉट इक्वल्स टू ज़ीरो दे नॉट कम्यूट। So, as I told you, to solve your quantum mechanical problems like operators, you must have to involve a wave function, introduce a wave function. So, to solve this problem, I must have to introduce a wave function which is, I am taking psi of x. So, let's introduce psi of x, just multiply your wave function psi of x with your operators. So, this is a commutation relation, A, B. So how we will open this? A, B minus B, A. So just open this x, P of x, A, B, okay, plus B, A, sorry, minus, multiply psi of x. So multiply your psi of x with this x, psi of x, p of x, minus p of x, psi of x, x. Okay? So what is the value of this momentum operator p? As I told you, p becomes equals to minus iota h cut partial by partial x. If I am taking momentum operator along x-axis, then this equals to minus iota h cut partial by partial x. So next thing is, put this value here in your relation. You will get x psi of x minus iota h cut partial by partial x minus p of x psi of x minus iota h cut partial by partial x. Okay, so what is common? Minus iota h cut is common, so you will get x psi partial by partial x minus you put the value of momentum operator here like minus iota h cut partial by partial x psi of x, and sorry for misunderstanding, so this is x. So minus iota h cut is common, so partial by partial x psi of x and x. So here two things, here two variables, one is psi and the other one is x. So derivative of two things means a, b, so you have to use product rule here. So open product rule here, minus iota h cut x operator, okay, this psi comes here, partial psi by partial x, minus product rule open here, one second derivative plus second first derivative. So psi of x partial x by partial x plus x partial psi by partial x. So partial d by dx by dx becomes equals to 1. So your becomes with minus iota h cut x partial psi by partial x minus psi of x plus x partial, sorry, here is minus, okay, minus, okay, so here is minus s partial psi by partial x. So see, two relations are same, so this cancels with this, you will get minus iota h cut becomes equals to minus psi of x. So multiply it with this minus iota, sorry, minus minus becomes equals to plus iota h cut psi of x. This is your right hand side and this is your left hand side. So just compare your right hand side with left hand side, you will get your final relation. So which is x p of x becomes equals to iota h cut psi of x, here also psi of x. So you see this psi of x cancels with this psi of x, you will get x p of x which are two operators becomes equals to iota h cut. So position operator and momentum operator along x-axis are getting answer iota h cut not equals to 0. So we can conclude in a nutshell, we can say our relation not commute. So our position operator x and along momentum operator along x-axis never commute. Okay, so we can also check different types of relations that position operator x with respect to momentum operator along y-axis. So this is your assignment, you can check by yourself either they are commuting or not, but here we prove this relation is not commuting. Okay, so this is a simple problem as we did earlier of what are operators, what are commutators. So this is a practical, simple example of operators and commutation relation. Okay, so different type of problems you have to done by yourself. Okay, so that's all. If you have any question, you can just leave a mail so I can reply you. Thanks a lot.